Hello friends, welcome back to the bench. This is a Z390 gaming motherboard. Very nice one with two M.2 slots, built-in Wi-Fi, USB Type-C, the SPDIF output. Very nice. Not a lot of, not very many USB ports, but definitely enough. And 6 SATA outputs, 3 PCI Express. I expect this one is full lane and this is half. Usually I didn't check even if I have a board view for this one. Probably not, but maybe I can find it on bot caps. Anyways, what's wrong with it? So as soon as I turn it on, see, it flashes. All these LEDs flash for a second, and it seems like it's dead, but we can turn it on. Which one is it? This one, right? The board is on, and one red LED. Actually, let me maybe bring the camera. Let's do it this way. Yeah, there's one LED, red LED, shining over here, and these are VGA, CPU, boot, and the RAM. So it's detecting that it doesn't have a CPU, and that's why it's not turning on. The second problem that I see with it, or the first problem actually, other than now I feel something warm here. There's something getting warm here. I'll check it out with a thermal camera. But before we do that, this port is damaged. Physical damage, obviously. So that needs to be replaced, or that shield can be, maybe we can only replace the shield on it, not the entire port or slot. Second issue, I need to grab a scope, is why does it not have a CPU installed? Well, because we have some bent pins, and let's see the state of them. No. Oh, there's one. There we go. And the other one. Okay, 1 second. There. Let's do this. Okay, that's enough. Enough. And there's one more here. Okay, that's good enough to test it. Let's try this baby. I'll test something like this. It's still only flashed. That's not good. And it still flashed the CPU. Oh, because I didn't connect the fan. Yeah, that could be it. Oh, now it's saying VGA. Yeah, which is correct. Yeah, but now everything's lighting up. but it should work off of internal VGA. Okay, let's turn it off. Let's see. Now I'm going to boot. Alright. Okay, we have an image. I didn't connect any mouse or keyboard or anything, but it's alive. So now all we need to do is just replace this nasty PCIe slot, and the board will be good to go. Alright, let's get to it. Alright, how do we replace this guy over here? Well, the easiest way would be just to put the flax on it on both sides, get the hotter station with no nozzle, and blow on this side until it just falls on the other side. Then just clean it, put the new one in. That would have been a nice and easy solution. However, you do need a little bit better device than this. This one is just not capable of delivering that much heat. So the other possibility with this would be using preheater from the bottom, giving it like 100 degrees, and then blowing with this from the top. That would work, but we don't have a preheater either. The other concern is that there's plenty of components on this side. Some chips over here, some capacitors there. We got plastic here, and we got two electrolytic capacitors. So there's a lot of concerns that we have around this socket. So I'm gonna choose the most tedious and most boring way possible, meaning we're just gonna wick every single pin one by one until they're all dislodged. For that to be successful, the soldering iron alone will not be enough. We will have to use some hot air blowing simultaneously. Before I actually even start putting flux on it or start the process, I will preheat the entire board with this, about 100-150 degrees, and I'm just gonna blow on it for a while for the board to get nice and hot, but not too hot. That will make it a lot easier to operate with my iron. And the tip I'm going to be using will be the chisel or knife tip, which is capable of conducting a lot of heat into the board. The temperature will likely be somewhere between 350 to 380, which seems like a high temperature, but I'll see how it goes. Sometimes when the temperature is too high, it's not working that great. We do need to heat up the wick along with the board and the solder for it all to flow. If we keep it hot for too long, the solder is going to start making its way to the other side of the board, and it'll hold the socket from this side really well, and it's going to be really difficult to get rid of it. The good or the easy part of it is that we don't need to reuse this socket, so we can damage the socket through the process of removal, because it is already damaged. Obviously, that's why we're removing it. There's not only this, because this could be straightened probably somehow, maybe, but the pins are bent in there, so we don't trust this socket. Plus the clip is missing on this side, so this took pretty big hit. As long as we take off the shield, so those big pins, the rest we can actually pull the port with some of the pins still on the board, because those pins are not very firm in the socket. If you pull too hard, you'll just the pins will stay on the board, and then we can individually remove those pins that don't want to get off. The main concern is obviously not to damage the board. There are some tiny traces on this side, so we're gonna have to be extra careful with that, not overheating it, and
trying to do it as clean as possible. The flux we're gonna use is gonna be MTech NC559. Very nice smell to it, I must say. I normally use Kingbow, but I'm kind of low on Kingbow, and it's RMA flags, which I don't know, you do need to clean it. This one technically, obviously you have to clean any flags, but this is NC, so it stands for no clean. We'll see how that goes. Alright, let's get to it.
Alrighty, so the port is out, no damaged pins, no damaged traces, one damaged capacitor, 220 nano, no big deal, I'll replace it. So this turned out to be extremely tedious, extremely difficult, and main reason is ground pins dissipate temperature a lot faster than the data pins. So data pins are easy to clean, easy or relatively easy to clean, while ground pins not so much. They just don't want to melt, the wick doesn't want to catch it, so I had to utilize a lot of hot air. Then wicking it also didn't work, and I must say the NC flax is not the best for this. RMA flax works a lot better for desoldering. Somehow the wick catches a lot better on the RMA flax. But I resorted to using solder sucker, just blowing hot air and sucking each individual pin, and that is the most effective. Now every socket, every through hole is clean, and it's ready for a socket replacement. I've lost the majority of the footage, but it was extremely boring. Actually, the only reason, because I couldn't really desolder all the pins because I wanted to just desolder everything and just pull the socket. That was the idea. Then, well, idea was that desolder the majority of them, then blow some hot air from the back and pull the socket, and it should come out clean. That did not happen. You can see only few pins actually let loose. The rest that are missing here stayed on the board, which means then I could just take the hot air, blow on it, and pull it with tweezer. And that's what I did. That actually was a lot easier and a lot quicker than trying to desolder pins from the other side. Either way, this is not the best method, but this is the best you can do with cheap tools like this one. It's perfectly capable of doing a lot of work, but not this work. The same if we wanted to resolder PCH or even some chips. Well, this one would be okay. This one we could replace, and this one, but PCH would be hard. The same with the CPU socket. That would also not be possible with this thing. All that requires preheater to just keep the board warm from the back, and then you can operate from the top, or the other way around. Anyways, as you can see, it is possible doing it in the very hard way. That's what this video is going to be titled. Doing it a very hard way, very inefficient way. But that's what you gotta do if you don't have proper tools. Alright, I don't have a socket to replace it with yet. It's coming to me over from China. So I'm gonna end the video here, and if anyone's interested, I might publish another video where I test it, because we don't know if it's even gonna work. But based on the visual inspection, everything should work fine. There's no damage to anything other than that one capacitor that I will replace as soon as I get capacitors as well. Alright guys, thank you very much for watching. Hope you found this useful in any way, and I shall see you in the next one.